Hi, this is Dr. Orijit Shah, Associate Professor of BP Poddar Institute of Management and Technology, Kolkata, India. Today, I will deliver a lecture on spatial domain image processing. Let's start with what is spatial domain? It refers to the image plane itself. The method based on direct manipulation of pixels in an image is spatial domain image processing. There are two important categories of spatial domain processing. What are they? Intensity or gray level transformation and spatial filtering. How is it denoted? It is basically denoted by the expression shown here, g of xy equal to t of fxy. Now here t is an operator which is operating on f, and f is the input image. So what is the output or processed image? That is g. T is defined over a specific neighborhood about a point xy. T can operate on a set of images. The principal approach for defining spatial neighborhoods about a point xy is to use a square or rectangular region centered at xy. Here we can see that the center of the region is moved from pixel to pixel, starting at the top left corner. Operator T is applied at each location xy to yield the output g at that location. Only the pixels in the neighborhood are used to compute the value of gxy. Here we can see we are taking 9 pixels at a time, and the blue point referred over here is the actual cell xy. What are the intensity transformation functions? The simplest form of the transformation T is when the neighborhood is of size 1 cross 1, which means a single pixel. In such case, the value of g at xy, that means the output, depends only on the intensity of f, that means the input at that point, and t, the operator, becomes an intensity or gray level transformation function. Intensity transformation functions frequently are written in simplified form as shown over here, t equal to P of R. Here R denotes the intensity of F, and S the intensity of G, both at any corresponding point xy. Now we want to discuss about some functions of IPT or image processing toolbox. The first function, ImAdjust. It is a basic IPT tool for intensity transformations of grayscale images. What is the syntax? Syntax is given over here. ImAdjust of F. F means the input function or input picture, low in, low out, high out, and gamma. The new intensity values in G is mapped by the ImAdjust function such that the values between low in and high in map to values between low out and high out. Values below low in and above high in are clipped to low out and high out respectively. Input image may be of class unsigned integer 8 or unsigned integer 16 or double, and the output image has the same class as the input image. All inputs to ImAdjust other than f have values between 0 and 1 regardless of the class of f. Using empty matrix for low in, high in, or low out, high out results in the default values of 0, 1. If high out is less than low out, the output intensity is reversed. The negative of an image can also be obtained with IPT function ImComplement. Now, gamma parameter we have not specified till now. Parameter gamma basically specifies the shape of the curve that maps the intensity value in f to create g. Here we can see 3 types of gamma values: gamma less than 1, gamma greater than 1, and gamma equal to 1. Now we discuss a very important function. It is implemented by using the expression g equal to c into log of 1 plus double of n. It is a logarithmic transformation function. Here c is a constant. Now shape of the transformation is similar to the gamma curve, with the low values set at 0 and the high values set to 1 on both scales. Log transformations is used to compress the dynamic range. It is often desirable to bring the resulting compressed values back to the full range of display. Mainly when the intensity value is very less, that means the picture is of blackish nature, then logarithmic transformation becomes a very useful tool to get the details of the picture, and it is done by gs equal to m to unsigned integer a mat to gray g. Use of mat to gray being the values of the range 0 to 1 and m to uint 8 brings them to the range of 0 to 250. I want to discuss now about the contrast stretching transformation. What is the function? Function is shown here. S equal to T of R equal to 1 by 1 plus m by R to the power e. Here R represents the intensities of the input image, S the corresponding intensity values in the output image, and E controls the slope of the function. This function compresses the input levels lower than m into a narrow range of dark levels in the output image. Similarly, it compresses the values above m into a narrow band of light levels in the output image, and it results in image of higher contrast. In the limiting case, the output is a binary image. Limiting function is called thresholding function. The equation is implemented in MATLAB as g equal to 1 divided by 1 plus m by double f plus epsilon to the power e. Here epsilon or EPS is used to prevent overflow if f has any zero values, because EPS is a very small number which restricts the denominator to become 0. How to handle variable number of inputs and outputs? To check the number of arguments input into an m function, we use function nargin, and n equal to nargin returns the actual number of arguments into an m function. In connection with the outputs of an m function, the function used is nargout. In a similar manner, n equal to nargout. We are showing here an example. T equal to test HV36. Use of nargin within the body of the function would return a value of 2, while use of nargout would return 1. Similarly, function nargcheck can be used in an m function to check if the correct number of arguments were passed, and syntax is message equal to nargcheck low high number. Function returns the message not enough input parameters if the number is less than low, or too many input parameters if the number is greater than high. If number is between low and high inclusive, nargchecks and returns an empty matrix. Now it is often required to write functions in which the number of input and output arguments is variable. For this, the variables var argin and var argout are used. In the declaration, var argin and var argout must be lowercase. Some example is given here. Function within square bracket mn equal to test hv3 var argin accepts a variable number of inputs into function test hv3. Function var argout equal to test hv4 mmp returns a variable number of outputs from function test hv4. If function test hv3 had, say, one fixed input argument x followed by a variable number of input arguments, then the syntax will be like this: function of fmn equal to test hv3 x comma var argin. This would cause var argin to start with the second input argument supplied by the user when the function is called. Now we come to a very important aspect of image processing, that is histogram processing. What is the histogram? Basically, a histogram shows the distribution of data values. Histogram of a digital image with L total possible intensity levels in the range of 0 to G is defined as discrete function hrk equal to nk. Here rk is the kth intensity level in the interval 0 to z, and nk is the number of pixels in the image whose intensity level is rk. Normalized histogram is obtained by dividing all elements of hrk by the total number of pixels in the intensity image, which is denoted as P of rk equal to h of rk divided by n, and h of rk is basically nk, so it becomes nk divided by n. For core processing of histogram in IPT, there is a function imhist, and syntax is imhist f comma b. Here f is the input image, h is the histogram, h of rk and b is the number of bins used in forming the histogram. Bin is simply a subdivision of the intensity scale, and default value is 256. For example, if we work with unsigned integer 8 image and let b equal to 2, then the intensity scale is subdivided into two ranges, 0 to 127 and 128 to 255. The resulting histogram will have only two values. H1 equals to the number of pixels in the image with values in the interval 0 to 127, and H2 equals the number of pixels in the image with values in the interval 128 to 255. Normalized histogram is obtained by imhist fb divided by numel f. Function numel gives the number of elements in the array f. Histograms are often plotted using bar graphs using the function bar horizontal v width. Here v is the row vector containing the points to be plotted. Horizontal is a vector of the same dimension as v and contains the increments of the horizontal scale, and width is a number between 0 and 1. If horizontal is omitted, the horizontal axis is divided into units from 0 to length of v. When width is 1, the bars touch. When width is 0, the bars are simply vertical lines. Default value of width is 0.8. If we want to equalize the histogram, then there is a function in IPT, hist eq. Hist eq f comma n lev, that is n level, is the syntax. Here f is the input image, n lev is the number of intensity levels specified for the output image. If n lev equal to L, the total number of possible levels in the input image, then hist eq implements the transformation function trk directly. If n lev is less than L, then hist eq attempts to distribute the levels so that they will approximate a flat histogram. The default value in hist eq is n lev equal to 64. For most of the general cases, we use the maximum possible number of levels, generally 256, for n lev, because this produces true implementation of the histogram equalization. The net result of histogram equalization is an image with increased dynamic range, which will tend to have higher contrast. Finally, we want histogram matching. It produces a transformation function that is adaptive, in the sense that it is based on the histogram of a given image. Method used to generate a processed image that has a specified histogram is called histogram matching or histogram specification, implemented by the function hist eq. And how is it written? Hist eq f comma h spec. Here f is the input image, h spec is the specified histogram, a row vector of specified values, and g is the output image. Generally, histogram of g better matches h spec when length of h spec is much smaller than the number of intensity levels in f. I want to thank you all for watching this video.